Hello दोस्तों, today we will discuss about enabling and disabling the port peripheral clock. So how to enable any peripheral, especially here we will discuss about the GPIO peripheral. So how to enable the GPIO peripheral clock. So we know that if you want to use any peripheral, then first you have to enable the clock because it is the heart of this peripheral. So there is basically a particular register present in the system that is called RCC, register clock control, uh, peripheral clock enable register. It is there is multiple register. Some register is known as RCC, A is beyond EN. So whatever the peripheral is connected with this high-speed bars, that peripheral can be enabled through this register. Similarly, AHB2 high speed bus 2, high speed bus 3. In this way, there are different bus present, and in this bus there are multiple peripheral is also connected. So to enable this peripheral, we have to enable the corresponding bus register bit. This register bit we have to enable so that we can use this peripheral. Okay, so there is also APB bus 1 and APB bus 2. So we have already seen that in our the memory map that which peripheral is connected in which bus. If you don't see that video, you can see that video from this playlist. So see that the first register is RCC AHP1 peripheral clocks. ENR means enable registers. Okay, so the offset value of this register is 0x30, and the reset value is also, the reset value is not 00. Okay, that is the reset value. There is the particular this mm, 23rd bit basically, not 23rd, it will be 19. Default value of 19 register is 1. Okay, so these are the register. If you want to enable the GPIO EA, if you want to enable the peripheral GPIO EA, then peripheral GPIO EA clock, then you have to write 1 here. For GPIO B, you have to write enable these bits. So in this way you can enable. So most of the peripheral GPIO peripherals are connected with this AHB1 bus. So using this registers, or you can enable or disable the peripheral clocks. So now, yeah, if you want to enable any particular peripheral, then corresponding particular bit you have to write 1. Okay, so now we'll discuss about the peripheral driver development. So how to use the driver so that we can use this driver in our applications. Okay, so that is basically the high level architecture. There are 3 level, that is low level, that is HAL layer, hardware abstraction layer, Then there another layer is driver. So then there is the application layer. So application layer generally use this driver function, and driver functions communicating with the hardware through the hell functions. So if there is any changes, then each layer is independent. Okay. So if there is any changes in driver layer, that should not affect the hell layer. So suppose we discuss that the sample of application. So that is the application developer write the code here. That is the application layer, and application layer use this driver layer. So we have already seen there is multiple peripherals. So every peripheral has its own driver, which GPIO driver dot C and dot A is present in this driver layer. For I2C peripheral, there is I2C driver C and H file also present in this way SPI word. So that peripheral has the uh, multiple uh, peripheral combinedly we called the driver. So now this how driver communicating with this microcontroller hardware. So that is the hell layer applications that is directly to the bit byte right into this corresponding hardware or directly to the memory location, that is GPIO SPI to see, that is the hell layer. Okay. So we have already discussed about it. So sorry. Now what is device header file and what's content? So we have seen that there is the C file and header file. So what content actually in header file? डिवाइस हेडर फाइल रहता क्या है इसके अंदर. सो दैट इज द हेडर फाइल, that is the header file which contain microcontroller specific details. So the header file basically they are saying the device header file, this one. Okay. So this header file, what information contain in this header file? That is the header file where contain the base addresses of various memory present in the microcontroller, such as flash memory, SRAM 1, SRAM 2, ROM. That's the, if there is also the EEPROM, then that information also present in this. This address is present in this header file, device header file, that is stm32 stm30a446.h. This header file contain that information, basically the address information, the base addresses of various bus domains, such as we have seen that the AHP and APP bus, APP123 and APP12, that's domain information. That address information also contained in this header file. Base addresses of various peripheral present in different bus domain. So the bus addresses and the every peripheral which is connected in this bus. Thus information that peripheral base addresses also present in this device header file bus domain of this microcontroller. Clock management macros, that the clock enable or disable macros also defined there, and the IRQ definition also present there. That is the how many IRQ available in our system and the IRQ number that's are present in this header file, and peripheral register structure definition. So what are how many peripherals are available, and there is the particular every peripheral has its one set of registers that are making a structure, and that is structure information. Peripheral register structure information also present there. Peripheral register bit definition, so every bits have its own definitions also. So peripheral register bit definitions also present, that this register bits what are the purpose of these bits. So that information also defined in this header file. Other useful macros, microcontroller configuration macros also present there. So that's the device header file. There is the that's content. We have divided in two parts. There is applications and driver files. Okay, device header file has this information, application information as well as driver. So applications also application and driver source file can include this specific header file to access the MCU specific details. So whatever microcontroller specific details has, that's information actually present in this file. So application also directly include in that files, and also the driver can include this header file. Mm. And the next lecture we will okay. In the next lecture, let's create the MCU device specific header file step by step. So whatever the this file how to create, we will discuss in our upcoming video. Okay, thank you.